Hey there, everybody. Welcome back. Math 44, College Algebra. We are in 2.3. This is applications for equations, for linear equations. In video A, we did all the geometry for rectangles, squares, circles, and triangles. Here we're actually going to apply them. So example 1, length of a rectangle is 1 less than twice the width. If the perimeter is 34 feet. Find the dimensions of the rectangle. All right. Assume you have that written down. We have a rectangle. And it says the length is 1 less. Is like a big equal sign. 1 less than twice the width. Remember, when we have less than, it subtracts and it does it after the thing that follows. So twice the width would be 2w. And 1 less is that. The equation for perimeter was 2L plus 2W. And we know that the perimeter is 34 feet. And we know that the length is 2W minus 1. And then I have that 2W. So all of this is in feet. I'm going to stop writing the feet part, but it's worth noting for later on. We have 30. 2 times 2W is 4W. 2 times -1 is -2. Then I still have that plus 2W. We collect like terms. The 4W and 2W go together to make 6W. And we can solve. We'll add 2 to both sides. And then we divide by 6. And we get W equals 6. And that's in terms of feet. Have we answered the question? No, we haven't answered yet, have we? It says that find the dimensions. The dimensions are length and width. We need length also. But we had length was 2W minus 1. So we can take W and put it in right there. L equals 2 times 6 minus 1, which is 12 minus 1. Length is 11 feet. I can do a quick check. $34, does that equal 2 times 11 plus 2 times 6? 34 equals 2 times 11 is 22. 2 times 6 is 12. And 22 plus 12 do add up to 34. So the answer to this problem is the width is 6 feet and the length is 11 feet. All right. That'll be it for this video. Oh, no, not this video, that problem. We still got more More problems to do. Don't get too excited. I bet you thought we were done. That would have been nice, huh? Next example. You know what? This feels more comfortable, but the camera is twisted wrong. Nope, wrong way. There we go. In a triangle, the first angle is 3 times the second angle. That should say times. And the third angle is 10 degrees more than the second angle. Find the angles. All right. So if the first angle is 3 times the second angle, and the third angle is 10 more than the second angle, sounds like the second angle is the smallest angle. We'll call that angle 2. This one just looks a little bit bigger. I'll call that angle 3, and that's angle 1. Remember, they add up to 180 degrees. And let's pick apart what we know from, or what the sentence gives us. The first angle is almost always an equal sign. 3 times the second angle. You know what? I'm going to call this A, B, and C. So this is A equals 3B. And this is A plus B plus C equals 180 degrees. Having that angle thing in there is just making the numbers look weird. So I'm going to switch to letters. We can do that. We're using variables here. And the other sentence says the third angle, so angle 3 is as an equal sign, 10 degrees more than the second. More than was add, and the second angle was B, and 10 more is add 10. So that gives us a relationship from C and B, and we have A and B. Let's plug in the information that we have. A is 3B, and C is B plus 10. I'm going to drop the degrees for now. We can collect like terms. There's 5B here. And now we start solving like we have normally. We'll subtract 10 from both sides. And we'll divide by 5. That looks like it might be 34 degrees. Let me check. $34 degrees. So B is 34 degrees, and that was angle 2. We need angle 1, and we need angle 3. Angle 1 was 3 times angle 2. So A is 3 times 34 degrees. I just wrote a percent sign. That is 102 degrees. And C was 10 degrees more. 34 plus 10 is 44. We can add up these degrees and see that we get 180 degrees. So we just did a check there and we got the angles of our triangle. All right, next example. I was looking up rates on DoorDash and Lyft and stuff like that in different towns. Oftentimes, and that's basically like a taxi. So taxi fare is $1.20 for the first mile. Nope, $1.20 a mile per mile with a $5.10 initial fee. If Juanita takes the taxi and spends $29.10 traveling, how far did she go? So let's reason out what's going on here. If the taxi shows up and she goes 0 miles, she still has to pay the $5.10. If it shows up and she goes 1 mile, she pays the $5.10 plus $1.20 for that first mile. If she goes 2 miles, she pays $5.10 plus $1.20 times 2 for 2 miles. So this is times 1 mile. I guess if I want to do this here, I could make this look similar. $1.20 times 0 miles. And we don't know how far she went, so let's call it X. If she goes X miles, she's spending $5.10 plus $1.20 per mile. And that should equal her total cost. So if we do that, we have $5.10 or plus $1.20 times X has to equal the total, and she spent $29.10. It looks like, since everything is only, I don't even need the 0 here. That's just to show it monetary wise. If I multiply everything by 10, I can get rid of the decimals. And I told you in a previous video, I don't like the decimals. Then we solve. It's 20, I think. 24 divided by 12 is 2, and there's 0. Yeah, it's 20. So it looks like she went 20 miles because this X was in miles. All right, I'm gonna pause it. We got one more video in this section. Not pause it, stop it. We got one more video in this section.